Welcome back. Today we are going to discuss an AP chemistry question. The link to this question has been given in the description of the video. The question is, carbon has an atomic radius of 77 picometer and a first ionization energy of 1086 kilojoule per mole. Based on periodic trends and the data given above, what are the most probable values for the ionization energy and atomic radius of nitrogen? 4 answer choices are given here. I will suggest you to pause the video here and try to figure out the problem by yourself. Hope by now you already have chosen the right answer. Now let us just do it together. So you can just Google search for a dynamic periodic table. Here it goes. So if we focus on the period 2, we can see carbon and nitrogen there. Carbon is in group 14 and nitrogen is in group 15. Carbon has an atomic number of 6 and nitrogen has an atomic number of 7. Now let us just have this information on the board. So it's already there. So we have carbon and nitrogen, they both belong to period 2. This period number is also known as N. This is very important. This is called the principal quantum number or the number of energy levels. So both carbon and nitrogen has 2 energy levels. Carbon is in group 14 and nitrogen is in group 15. The group denotes the number of valence electrons or the electrons in the outermost orbital for the atom. So for carbon it is 14 minus 10, 4, and for nitrogen it is 15 minus 10, 5 valence electrons. Carbon has an atomic number of 6 and nitrogen has an atomic number of 7. The atomic number is same as the number of protons. Now we know that the proton is positively charged. They reside in the nucleus. So Z, the total nuclear charge for carbon, is positive 6 and for nitrogen this is positive 7. Now the question discusses about the atomic radius and first ionization energy. Now let us just see what do they mean by that. So if you have a diatomic molecule where you have 2 atoms of the same element and this is the distance between their nucleus, then the atomic radius is just the half of that. So it is half the distance between the nucleus of 2 atoms of the same element. Now what is ionization energy? Now if you have an atom, this is the nucleus, this is the orbital, and they have, for example, 2 electrons here. So ionization energy is the energy that you need to provide in order to take these electrons away. So this is a neutral atom. If I provide the first ionization energy, what will happen? Now this will become, this will be left with only 1 electron and it will lose one of its electrons, so it becomes positively charged or cation. So by providing ionization energy, we actually are converting an atom to its corresponding cation. This is the first ionization energy. This is the energy to take away the electrons, the first electron from a neutral atom. Now subsequently, if you provide more ionization energy, we will take away the other electrons from its ion. Now here we will have to compare the atomic radius and the ionization energy of carbon and nitrogen. For that, let me just draw this out. So this is carbon, this is its nucleus and it has 2 energy levels because its N is 2. Now it has a total of 6 electrons because a neutral atom is always having the same number of protons and electrons. So the total number of electrons is 6. Now how will I know that how many electrons go to each energy level? For that we have this common formula that is called 2n square, where n is the energy level. So for the first n, when n is 1, 1 square is 1 and times 2 is 2. So we will place 2 electrons in our first energy shell. So this is the maximum number that they can hold. So if n is 2, 2 square is 4, 4 times 2 is 8. So in the second energy level, they can hold a maximum of 8 electrons. But how many total we have? We have 6 for carbon. We already have 2 in the first shell. So 6 minus 2, 4 are left, which we are going to put in the second orbital. Anywhere here in the second orbital. So that's carbon. Now let me just draw nitrogen here. So this is nitrogen's nucleus. This is the first energy shell. The second energy shell, we already know that how many electrons goes to the first shell, that is only 2. And the second shell can hold up to 8 electrons, but nitrogen has a total of 7 electrons. 2 is already filled out in the first shell, so 7 minus 2 is 5. So we will have 5 in the second shell. 1, 2, 3, 4 and 5. Okay, so these are the atoms. Now let us just write down that how many nuclear charge each of them is having. So we know that they have a positive 6 charge in the nucleus and they have a positive 7 charge in the nucleus. So this nuclear charge, positive charge nucleus, they are attracting the electrons in both cases. But also if you see, for the outer electrons, they are actually shielded by the core electrons. Core electrons means electrons in the inner shell. Electrons in the inner shell are called the core electrons. They are actually repelling the outer electrons. So the repulsion of core electrons to the outer electrons, this is called shielding or screening. So due to this repulsion, the hold of this positively charged nucleus on the outer electrons will be weaker, and we can actually quantify it, which is called the Z. Z is the total nuclear charge effective. Z effective is given as Z, the nuclear charge, minus S. S is the number of core electrons. So let us just find out what is the Z effective for this carbon and nitrogen. So for carbon, the Z effective is plus 6 and they have 2 core electrons. So this is plus 4. And for nitrogen, this is plus 7 minus 2. They have the same number of core electrons. So that equals plus 5. So as you can see that nitrogen has a greater effective nuclear charge. So what will happen? It will try to pull the electron, the outer electron, more effectively than in case of carbon, because it has a higher effective nuclear charge. So what will happen if the force from the nucleus is greater? So the size, if I draw now here, this is carbon. If this is the size of carbon, so what will be the size of nitrogen? The size of nitrogen will become smaller, because the nucleus, the positively charged nucleus with a more effective positive charge of plus 5 is pulling the electrons with a greater force, especially the outermost electron. So we can see that if we go from carbon to nitrogen, the size decreases, or alternatively if we go from nitrogen to carbon, the size increases, the atomic size increases. So actually this is the general trend of the periodic table. So if you go across the period from right to left, the atomic size increases. So if carbon has an atomic radius of 77 picometer, we know that nitrogen will have a lower atomic radius. Now let us just see first which answer choices actually obey them. For A, yes, 70 picometer is less than 77, so A is a possible choice. And 86, no. 135, no. And then D, 40 picometer is less than 77 picometers. So either A or D will be the right choice. Now we still need to determine the ionization energy. Now this is very obvious. If I have, so this is the size, right? This is the atomic size. So the size is decreasing as we go from left to right, or increasing from right to left. So what will happen? Where I will have to give more energy in order to snatch the electrons. So if I want to snatch one electron in both of the cases, so since this has less hold for the nucleus on its outermost electron, I will have to give less energy here. And here the pull for the nucleus is more for the outermost electron, so I will have to provide more energy here. So for ionization energy, what will happen? I will have to give more ionization energy for nitrogen because it is smaller, and less for carbon. So this is the actually general trend for the periodic table. As you go from left to right, the ionization energy increases because the size decreases. So now we can finalize which one will be the right choice. So we had the options of A and D. Both have the atomic radius for nitrogen less than carbon. But the ionization energy will have to be greater than carbon. The ionization energy of carbon is 1086, 1402 is greater than 1086, but 995 is less than 1086. So only the answer choice A is what we are looking for, that nitrogen has a less size, it will have a lesser atomic radius and a greater ionization energy, as we have explained here and we have seen here that the size increases here and the ionization energy increases here. Thank you all for watching my video. Please like my video and subscribe to my YouTube channel Circle Research and Education, where I post test prep videos for PSAT Math, SAT Math, ACT Math, AP Chemistry and AP Biology questions, and also dashboard analysis. Blag Darya was. See you in my next video then. Happy learning!